So dear students, our next heterocycle is a fused heterocyclic moiety, which is quinoline. So quinoline, the structure of quinoline is like this. Okay, so this is the structure of quinoline, and number 2, the quinoline ring follows this order. Nitrogen is always given the first position. Okay, so this is how we give numbering to quinoline, and it can be considered, a quinoline is considered as if it is obtained from naphthalene. What is naphthalene? Naphthalene is two benzene rings fused with each other like this, and when you insert a nitrogen, replace a carbon of the ring by a nitrogen atom just adjacent to the fused arm, you get quinoline. Okay, so this is how quinoline can be assumed as the derivative of naphthalene. Okay, there is one more thing. If quinoline is at just second position, if it is not at the first position, say if it is at the second position, now this will be called as isoquinoline. As because quinoline is considered as the derivative of naphthalene, the other name for quinoline can be 1-aza-naphthalene. Okay, now quinoline is a colorless liquid. It is a colorless liquid having a boiling point of 237 degrees Celsius. It was first isolated in 1834 from coal tar. Okay, they are also called as quinoline and isoquinoline are also called as benzopyridines. Because if you break down this ring, quinoline ring, into two parts, you will see that one is a benzene ring and other is a pyridine ring. Okay, now quinoline is weakly basic. It undergoes electrophilic substitution at C5 and C8. For nucleophilic substitution, the best positions are C2 and C4. Let's move on to the synthesis of quinoline. Method of preparation of quinoline. The first, a very famous reaction for quinoline preparation is scarab synthesis. Scarab synthesis. In scarab synthesis, aniline is reacted with acrolein, an alpha beta unsaturated aldehyde. So what we have in reaction is, we have aniline and we react this aniline with acrolein, acrolein, you can see that it is an alpha beta unsaturated aldehyde. So in presence of acid at 130 degrees centigrade, followed by oxidation, quinoline is formed. Okay. The second synthesis for preparation of quinoline is Friedlander synthesis. Friedlander synthesis. So in Friedlander synthesis, what we do is we have an aldehyde having NH2 at the alpha position. This is orthoaminobenzaldehyde. Orthoaminobenzaldehyde. Now this orthoaminobenzaldehyde is reacted with acetaldehyde, CHO, in presence of base sodium hydroxide and ethanolic environment C2H5OH. The water molecule gets removed and this amino group reacts with the carbonyl group of CHO, and you know that when an amino group reacts with aldehyde or ketone, Schiff bases are formed. So there will be a formation of amino compound which is called as Schiff base. Now after the formation of Schiff base, there will be ring closure, and due to ring closure, quinoline is now formed. Okay, so this one is Friedlander synthesis. Now the next synthesis is Fitzinger synthesis. So in Fitzinger method, what happens is that we have istatin. We start from istatin. We start from istatin and we react this istatin with KOH, potassium hydroxide. Due to potassium hydroxide, a hydrolysis is observed. Bond is broken. This amide bond that you see here gets broken, and we get a potassium salt of the acid, isatoic acid. Now in the help of ketone, a cyclization is performed and we get quinoline. A substituted kind of dough. Now protonation can be done, and if heated, this molecule will give a substituted quinoline derivative. Now next is Combe's synthesis. What happens in Combe's synthesis is that we have a dicarbonyl compound CH3 C double bond O, CH2 C double bond O, single bond CS3. You react it with an orthomethoxyaniline derivative, and you give heat, and there is a presence of concentrated H2SO4 followed by hydrolysis, and we get quinoline. So this is COMS synthesis. Now moving on to our next method of preparation. This is Dobner-Miller synthesis. What happens in Dobler-Miller synthesis is there are 2 moles of acetaldehyde. They are heated in presence of HCl first, and aniline, is there. So these are heated and we get 2 moles of Schiff base. When this Schiff base is reacted with acid, a cyclization of the molecule happens, and a partially saturated quinoline ring is formed. Now then, aniline is removed, and followed by oxidation, we get a substituted quinoline as our product. Now next method is called Pictet method. In Pictet method, we use N-ethyl acetamide N-ethyl acetamide. We then react it with zinc chloride as a catalyst, and we see that a shift of C2H5 happens. That would be a kind of electrophilic substitution reaction, and alkyl group is shifted to the benzene ring. Followed by the cyclization process, we get 2-methyl quinoline. Okay. Next is Conrad-Limpach-Knorr synthesis. Conrad-Limpach-Knorr synthesis. In Conrad-Limpach-Knorr synthesis, we have aniline, and this aniline is reacted with ethyl acetoacetate. At 40 degrees centigrade, it is first heated, which forms Schiff base, because there is a amino group and it reacts with the keto group of the molecule. So we get a Schiff base. Okay. Now when you heat this Schiff base at 260 degrees centigrade in presence of alcohol, at 260 degrees centigrade, the alcohol part, the ester will get hydrolyzed and there will be a cyclization. Ester will be hydrolyzed, the ethyl alcohol part will get removed and we get a quinolone derivative. This is 4-quinolone. We can also get 2-quinolone by just changing the conditions of the reaction. So let's say if we heat it to 140 degrees centigrade, there will be a change in the reaction. A different product will get formed. There will be nitrogen, NH, C double bond O, CH2, C double bond O, single bond CH3. It clearly means that nitrogen is now attached with the ester functionality and not the keto group. So this molecule is formed, and heating it to 250 degrees centigrade brings dehydration and leads to the formation of 2-quinolone. So 2-quinolone is also formed. Quinolone is also formed. Okay. Now the last reaction through which we can form quinolone is by indole. Indole is another fused heterocyclic compound. It is composed of two rings. One is benzene and other is pyrrole. So therefore it is known as benzpyrrole. This is a very important heterocyclic moiety, and when we react this heterocyclic moiety with chloroform NaOH, a ring opening and ring expansion will take place, and we get 3-chloroquinoline. Now this is all about method of preparation. Now coming to the chemical reactions. In quinoline, there are several reactions that can be done, but first you must know that quinoline is a weak base. The main site of electrophilic attack, the place at which electrophile will attack, is the nitrogen atom. It is the first position, N1. Nitrogen atom will attack. This is N1. This nitrogen atom, it decreases it reduces the propensity of quinoline ring towards electrophilic substitution reaction. Hence, whenever we want to do electrophilic substitution, it requires vigorous condition. Okay. So let us see one by one the reactions given by quinoline. Okay. So the first reaction in the queue is addition to nitrogen. Now nitrogen can react with a variety of reagents. So this nitrogen is very reactive in quinoline, and it can attack a variety of reagents. Like if you react it with HCl, the proton will be accepted by this nitrogen because this nitrogen is of a pyridine kind of nitrogen. It is having a lone pair of electron which it can easily give to this hydrogen, and it can acquire positive charge. So a salt can be formed. It can also react with Lewis acids like AlCl3 in presence of acid in the acidic condition, and it can also gets attached with aluminium trichloride. Now you can see that it will not be able to give a Friedel-Crafts reaction because the nitrogen directly reacts with AlCl3. This quinoline can also react with acetic anhydride, which is a very famous acetylating agent. You all know about it. Okay. So this acetic anhydride can also react with quinoline and can form an N-acetylated derivative. So these are the reaction of the nitrogen group. Now quinoline can also undergo electrophilic substitution reaction. So I have already told you the preferred site of electrophilic substitution would be your position number 5. Okay, either it would be position number 5 or it would be position number 8 as well. So let's say we are talking about electrophilic substitution. And we say that C5 and C8 are the main sites. So let's say we react with HNO3H2SO4, and you know that HNO3H2SO4 is a nitrating mixture. Hence we are doing nitration process over here. So you will see that while electrophilic substitution, NO2 group can attach either at position number 5. This is position number 5. If you want to know the positions of the carbons, so this is the position. So nitrogen either attaches to position, NO2 either attaches to position number 5 or it attaches to the position number 8. The similar condition happens with bromine. So bromine in presence of AlCl3, it does react at position number 5 or 8 to give bromo substituted quinoline. You can also try to react with H2SO4 SO3, and you know what will happen at 90 degrees centigrade. Sulfonation can be done either at 5th position or at 8th position. So both 5 substituted and 8 substituted products are now formed for the electrophilic substitution reaction. Now let's talk about acylation and alkylation. Acylation and alkylations are not done in quinoline, but they are done only when there is an electron donating substituent in the molecule. So let's say we are having a methoxy group which is an electron donating group at the 8th position, and we want to attach a CH3CO group on it. So this CH3CO group will be attached at 5th position. Otherwise, if had there been no OCH3 group at 8th position, it will not prefer acylation or alkylation. Now the nucleophilic substitution reaction. As I have already told you, it gives nucleophilic substitution reaction, quinoline gives it, and the preferred position for nucleophilic substitution is 2nd. So let's say if you react the quinoline with NaNH2 sodamide, which is a source of NH2 negative ion, it will attach this NH2 at the 2nd position. You can also attach many other groups like alkyl, like butyl group at the 2nd position. So this is the nucleophilic substitution given by quinoline. Many other groups in quinoline can also be replaced by the reagents. Let's say we are having bromine at the 3rd position and we want to replace it with NH2 nucleophile. So there will be a nucleophilic substitution reaction and this bromine will get replaced by the NH2 group. So this is how quinoline undergo nucleophilic substitution reaction. Now what about oxidation? The reaction of oxidation of quinoline is very important, because if you try to oxidize quinoline, you will see that let's say we are oxidizing it with KMnO4, so you will see that it forms a pyridine dicarboxylic acid. It is known as quinolinic acid. Okay, quinolinic acid. And when you heat, a decarboxylation happens and one of the COOH group gets removed from it and we get niacin, or we call it nicotinic acid, which is a vitamin called as niacin. So this is how the oxidation reaction of quinoline is very important. Now coming to the last chemical reaction given by quinoline is reduction. So if you perform the reduction of quinoline, you will see that at room temperature quinoline can get reduced by hydrogen atom and can form a partially substituted quinoline. So this particular name is, the name of this particular is 1, 2, 3, 4 tetra hydroquinoline. So these were all about the chemical reactions of quinoline. Now let us see the applications in drugs, in pharmaceuticals. So as you know, quinoline is a very important drug. It is a core component of chloroquine, a very famous anti-malarial drug. Its isoquinoline is also found in papaverine. It, uh, it its isoquinoline part is found in papaverine. It is also found in quinapril, an antihypertensive drug. Antimalarial hydroxychloroquine also contains the quinoline moiety, and many other drugs like antidepressant, narcotine, amytine, they also contain quinoline. And there are many more drugs as well which I have not mentioned here. Quinoline is found as one of the core component in those drugs. So I hope you have understood all about quinoline, and now we will move on to our next drug, next heterocyclic moiety, which is isoquinoline. Okay, thank you.